So let us see the topic electricity. Basically, electricity is what? We can say that in our houses, the electric supply came. Means the bulb get lighted, or all the appliances work which we have in our houses. So basically, we can say that electricity is basically coming of the current from the power station. We basically, in layman language, we say that. Okay, so electricity is, if we study in you can say in technical language, so what is electricity? Basically we have to understand that. So electricity is nothing but it is just having, you can say that movement. Electricity means basically the movement of the electric current, and the movement of electric current determines the movement of the electrons. Suppose actually we know the basic from that electrons and protons, these are the basic structure of the atoms. So basically I want to tell that electrons, it is let us suppose this atom, and it contains proton and electron, we know, right? It contains proton and electron, we know very good. So basically what is electric current? Electric current is the, you can say, you can write the movement of electron, movement of electron. So whatever the electron movement is there, it is the movement of electricity. We know the basic structure of atom, but you know that before knowing the basic structure of atom, before knowing that atom contains electron, proton and neutron, electricity has been developed. Actually before the discovery of the atom, that what the structure atom contains, a battery has been invented before that only, and battery has been invented, and when the battery has been invented, then at that time only it has been decided that the electron, we can say the current flow from positive terminal to negative terminal of the battery, we know, and that time also there is a thought that current flow from positive terminal to negative terminal, they all are saying. So they have said the actually the current flows from the positive terminal to negative terminal. But when the atoms get discovered, and we know about the electron and proton, and we have seen that when applying the battery, actually the electrons going to move from negative terminal to positive terminal of the battery, means from negative terminal to positive terminal of the battery, electron is going to move. So basically we have to tell that the movement of electron, that is from negative terminal to positive terminal, is electricity. But it has already been determined by the people who have invented the battery, that the movement of the current is from positive to negative. So we have told that movement of electron in opposite direction, movement of the electron in opposite direction is called the electric current. Movement of the electron is always from the negative to positive terminal, but the electric current movement is from the positive to negative terminal. So basically you can say that movement of the electron is the electric current, and it is the electricity. So electron is what? It is charged, negative charge particle. So from here we can say the definition of the current. Then what is current? First of all we have to say what is current. So right, current, what is current? Current is basically movement of charge, and charge is what? It is electron only, right? So movement of the charge per unit time, that is current. Movement of the charge per unit time, that is current. We have to remember movement of the charge per unit time is current. So actually current is represented by small I, and small I is equal to charge per unit time. So movement of the charge per unit time, it is current, and its unit is ampere. Its unit is ampere because it is invented by the scientist Ampere. So its unit is ampere. So please remember, current is nothing but it is the charge per unit time. Okay. So now let us move towards the potential difference. What is potential difference? What is V? So write the definition. First of all, write the definition. You write here potential difference. Then we will discuss in detail. Potential difference is denoted by capital V. Potential difference is denoted by the capital V, and please write the definition. Work done. Make a line here. Work done per unit charge. Work done per unit charge is potential difference. Work done per unit charge is potential difference, right? You can write like this, work done per unit charge, and it is denoted by volt, because the scientist Volt has invented this potential difference. So basically two things you have to remember. First of all, you have to remember this current, charge per unit time, and second thing you have to remember this potential, which is work done per unit charge, okay. This both you have to remember. Now let us move towards other thing. So we have noted till now what is current, what is potential difference, work done per unit charge is potential difference. Basically you have to remember like that only, and the unit of the potential difference is volt, and the unit of the current is ampere. Now let us move towards the Ohm's law, okay. So put the heading Ohm's law. Scientist Ohm what the scientist Ohm has told. Scientist Ohm has told that, let us suppose take a battery, okay. Let us suppose take a battery and take a wire. First of all, take a wire, having the you can say take a wire, okay, and this is wire W, and take a wire and take a battery of potential difference V, right? And let us suppose current I is flowing here, okay. Let us suppose current I is flowing here. You can say like this, current I is flowing here, okay. Now what Ohm's law has said, we have to remember this. Ohm's sir has told that voltage means if any circuit element, you can say it is a circuit element, right? Any device, any circuit element is there. Here what Ohm's law has told. Ohm's law has told, as we applied a potential difference, let us suppose we have applied a potential difference 1 volt, okay. So we have applied a potential difference 1 volt, and the current flowing through it we have measured by ammeter. Let us suppose here ammeter has been put here, okay, and voltmeter has been put here, okay. So we measured V, that we have applied V equal to 1 volt, and ampere current we have applied 1 ampere, right? Okay, we have put all that by ammeter and voltmeter. Ammeter is basically used for measuring the current, voltmeter is basically used for measuring the potential difference, right? Now what happens, we see that when we increase the voltage by 1 volt, means now we will take voltage at 2 volt, and current also we take 2 ampere. In the similar way, 3 volt we keep on increasing by 1 ampere, 3 ampere, like that we are going. We will find that V is directly proportional to current. One relation we will find, that across this circuit element, we will find that the potential difference across this circuit element is directly proportional to the current, flowing through it. You can see 1 volt we have applied, you will get 1 ampere. 2 volt applied, you will get 2 ampere, like that you will get. So if you remove this proportionality constant, we will get V equal to I into R. And basically what is this R? This R is basically the resistance of the circuit element, right? So from here we can say that V upon I means if we increase V from 1 volt to 2 volt and from current 1 ampere to 2 ampere, it is 1 ohm only. This resistance is actually it is called the resistance, first of all remember, and it is denoted by capital R, and its unit is, we can say, ohm, or we can symbolically represent like this, okay. So keep remember this. And now we will see, as we increase the volt by 1 volt, now we will increase up to 3 volt upon current 3 ampere, again resistance is 1 ohm. So we will see that on increasing linearly voltage, current also increases linearly, and the resistance, or you can say the proportionality constant of the circuit element, keeps constant. Means here slope is constant, but voltage and current is varying linearly. This all are done by the experiment in the lab, okay. So from here we conclude that please write what we have concluded, that voltage varies directly proportional to current. V is directly proportional to current, or we can say V equal to IR. This is the relation of Ohm's law. This is the relations of the Ohm's law. Here we have assumed that temperature variation is limited. Temperature variation is limited. So now, if we want to draw the graph, then we will see that, let us suppose it is voltage, it is current axis, it is voltage axis. Then we are going to get a straight line graph. Then we are going to get a straight line graph like this. And if we want to know the slope, so we can see, actually we know the slope equal to y2 minus y1 upon x2 minus x1. So we will basically know that this is constant. This is constant, right? So basically this is the Ohm's law, and current and voltage I have explained well. So sir, this is my demo video. I think you will like this, and if you like this, sir, I will be waiting for your reply that I will going to have the academic interview by you. Okay sir, thank you.